Hey, so we're going to do the practice problems for Unit 7.4, Lesson 7. I've decided to work in the book this time, so you'll see that I've got the book up on the screen. Um, Obviously, if you're in my class, you have the choice to do it online or in the book. I think if you're in Mr. Wong's class, you're supposed to do it in the book. So if you are choosing to do it in the book, it's pages 68 and 69. Let's go ahead and get started. The warm-up says, if x represents a positive number, circle all of the expressions whose value would be greater than x. I see that in each one of these expressions, x is being multiplied by something. That's what it means when you put a number right up next to a variable, or when you put a variable right up against some other expression inside parentheses. The parentheses tell you to multiply as well. And so I know that if I multiply any number, which I guess in this case will be x, by something bigger than 1, then the product or the result will turn out bigger than x originally was, or whatever that original number was. If I multiply by something that's smaller than 1, then the product or the result will turn out smaller than whatever x was at that original number. So I'm just going to look for the ones where x is being multiplied by something bigger than 1. I know that product will turn out bigger than x. Everything I just said only works because x is a positive number. If they didn't give us that information in the question here, then the rules are a little different. All right, so I look at D. I see that x would be multiplied by 1 1/4, right? After you add the 1 plus the 1/4, and so that one would turn out greater than x. Over here, I see 9/8 times x, and 9/8 is greater than 1, so that one would turn out greater than x. Here, x is being multiplied by 7/8, which is less than x. And here, 1 minus 1/4 is 3/4, so this would turn out less than x. You could kind of relate these to increasing something by a certain percent. This is essentially what we're doing, just it's expressed as fractions. And you could relate these to decreasing something by a certain percent, but just expressed as fractions rather than percents or decimals. All right, so next, it says, decide whether diagram A or B represents each of these situations. So 1.1 says, the amount of apples this year decreased by 15% compared to last year's amount. Okay, so I look at diagram A, and the 15% here looks like it's being reduced off the total length of 100% from the previous year. Whereas over here in diagram B, it looks like the 15% is being added on beyond the original 100% from last year. So this one is essentially going to be my decrease diagram. And this one is going to be my increase diagram. It's pretty much as simple as that. If the question's about a decrease, I'm probably going to pick A, and if the question's about an increase, I'm probably going to pick B. So 1.1, I'm going to say it's diagram A. 1.2, the amount of pairs this year is 85% of last year's amount. Having 85% of some other amount is the same as a 15% decrease from that amount. So I'll go with A. 1.3 says the amount of cherries this year increased by 15% compared to last year's amount. So that's going to be an increase. So I'll choose B. And the amount of oranges this year is 115% of last year's amount. Having 115% of your original amount is the same as a 15% increase. So I'm going to choose diagram B. All right. Question 2 is a really tricky one that is, hopefully you kind of picked up on the idea of question 2 doing today's Desmos lesson, the percent machines. Well, actually, I don't know. I don't know if that lesson has that many great examples of this type of question. It's a tricky one. Let's talk about it. I might even have to use a little scratch paper to kind of explain my thinking on this one. So it says, Mateo's aunt bought a share of stock many years ago. The value of the stock increased by 80% and is now worth $270. What was the value of the stock when Mateo's aunt bought it? All right, first thing I'm going to do is show you an incorrect way to do this question, the way that I would expect many students to mess this question up. And then let's talk about why that's wrong and how to do it correctly. So this would be incorrect. So the new price of the stock is, I believe, $270, right? And we know that's an 80% increase from the original. And now a big mistake that a student might make is to say, okay, well, let me just take 80% away from $270, right? Like, let's say this is the original stock price. And we know that to go to the new stock price, which is more, so I'm going to make it a bigger circle. This is the $270. We know that this is supposed to be a 80% increase. So I'll write 80% up. And so a mistake that a student might make is by thinking, oh, well, then if I just decrease $270 by 80%, I'll get back to the original amount. That's not a good strategy for this. And that you should have picked up on in the percent machines lesson for today. This whole idea that starting here and increasing by 80% is not the same thing as starting here and decreasing by 80% to try to get back to where you were. Let's try it though. So if you had $270 and you multiplied that by 20% or 0.20, because that's the same thing as an 80% decrease, right? If you take 80% away from something, you have 20% left. You do this, you get $54. And so remember, this is still an incorrect answer. You would incorrectly think that the original stock price was $54. But now if you put that in this diagram, you realize, wait, if it was $54 to start with, and it was eventually worth $270, that's way more than an 80% increase, right? This is more than double. This is more than triple. This is 5 times bigger. You would multiply 54 times 5 to get to 270. And something you might notice about that is, wait, we multiplied by 1/5 to get 270 times 1/5 got us 54, right? I did 0.2 over here, but that's the same as 1/5. And so if you reverse that, that means that 54 times 5 equals 270. And so we didn't get anywhere near this number we were looking for, that when increased by 80%, it gets us 270. We got a number that you have to increase 5 times in order to get to 270. It's not even close. So here's how I think you should approach this question. The original amount that we want to find is unknown. The new amount is 270. If you're in my class, you should be getting used to me using these words original and new, but the original amount is the same as your whole amount that we've talked about a lot, and the new amount is the same as your part that we've talked about a lot. And we know how to handle questions with whole and part as long as there's a percent involved, right? That's the other piece. Well, I want to think of the percent in this case as 180%. And the reason for that is I know that the original amount or the whole amount starts off as 100% of itself. And then the new price is supposed to be 80% more of that. And so what I'm saying here is that the new is 180% of the original. And now I can use this formula that we've done a lot, is the whole equals part divided by percent. You did a Google form homework in both mine and Mr. Wong's class, like maybe there's a week or so before Thanksgiving break, that had 5 questions on it. And they were all just like this, these tricky ones like this, where you have to think about where your percent is coming from. And they usually wind up using some form of division to solve. And so my original whole is going to equal this new part of 270 divided by 180%, but I moved the decimal point over 2 spaces to represent it as a decimal. So I'm going to divide by 1.8. That I actually don't know off the top of my head. I'm going to grab my phone to make my life easier. I'm going to guess it's, well, if I was dividing by 2, it'd be 135. So this should come out to be like maybe 150 or so, would be my guess. Let's see. 270 divided by 1.8. Hey, 150, I guessed it. And so that answer should feel a lot more reasonable, right? If 150 increases by 80%, it comes to 270. Whereas $54, that didn't seem like a reasonable answer when you think about the question. So I think the moral of the percent machines lesson from today, and this question here about Mateo, is that you have to always remember that your percents are coming from your original or your whole amount, and be really careful with the way you handle questions based on like that knowledge. All right, so 3.1 says, what is 18% more than 61? Okay, so this time the 18% is coming from the 61, so we just have to raise 61 by 18%. My favorite way to do this is to just say, well, the original 61 is 100%. Oh, I'm a little bit off the screen. And I'm trying to raise that by 18%. So I want an extra 18%. That equals 118%. So I want 118% of 61. I move this decimal point over 2 spaces to represent 118% as a decimal. I'm going to do 1.18 times 61. 1.18 times 61, 71.98. Be comfortable with your answers not always coming out to perfect whole numbers, especially when we're doing this percent stuff. All right, number 3.2 says 10% more than a number is 132. What is the number? Okay, so this is another one where we got to be careful, like the Mateo question previously. A mistake in this question would be to say, okay, so 132 is 10% more than this number that I want. So I'll just take 10% off of 132 and get the number I want. It doesn't work that way. You can't go back and forth with the same percent in that way. Just like, with proportional relationships, you have to remember if you're going from X to Y, you multiply by your K. When you're going from Y to X, you divide by your K. Or with scale drawings, when you went from one drawing to the other, you had to remember to flip the scale factor. Percents are similar in that way, where you can't use the same number or the same operation, at least in both directions. You have to be really careful about which direction you're going. And so in this case, the original number is unknown. And we're trying to get to this new number of 132, and we know that it's an increase of 10%. Well, the way I would think of that is then that 132 must be 110% of the number I'm looking for, right? The original number, whatever that number is, we don't know it yet, is 100% of itself. And then 132 is 10% more than that, so 110%. And now I'm going to use the same formula I used up here. It's still on screen, good. So if I'm trying to get back to my whole or original number, that's going to equal the part or the new number divided by the percent. And so I'm going to do 132 divided by, not 110, right? Move that decimal point over 2 spaces and divide by 1.1. Let's see what that gets us. 132 divided by 1.1 gets us 120. And that's slightly different than if we had just taken 10% of 132 and subtracted it off. 10% of 132 is 13.2. When you subtract that off, we would have got 118.8, I think. I think that's right. So the answer is a little bit different. All right, and then 3.3 says 140 is what percent less than 160? Okay, so like essentially what they're asking here is what what number would you have to decrease 160 by in order to get 140? There's a lot of different ways to do this question. I'm going to do what I think is the most natural or normal way. First, let's just figure out what's the difference between these two numbers. It's 20, right? You have to take 20 off of 160 to get 140. And so if we just figure out how much 20 is out of 160, that tells us our percent decrease. So I want to do 20 divided by 160. I see that that's the same as an eighth, right? I'm doing some fraction simplification there. And 1/8, this is one that I think I told my students to memorize at some point. I don't know if Mr. Wong says he's memorized, but you can convert 1/8 to a percent. It is 12, oops, I don't know why I wrote that too all small and weird, 12.5%. So what that means is you need to take 12.5% away from 160 to get 140, or 140 is 12.5% less than 160. All right, I'm going to move up to the top of the next page. Let me adjust this thing. Okay, so it says determine how many feet each member of Lola's family walked. 4.1 says Lola's pet turtle walked 10 feet and then half of that length again. Okay, so 10 feet plus, this one's not too hard, right? We can do this one in our heads. Half of 10 feet is 5 feet equals 15 feet. But I think what they're trying to relate this to is the fact that that extra half is like an increase of 50% here, thinking of it in terms of what we're studying right now. Right over that, like the original 10 feet that the turtle walked, 50% more. Okay, the next one says Lola's baby brother walked 3 feet and then half that length again. Okay, so this is 3 feet plus whatever 3 divided by 2 is, right? Half of 3. Let's see here. 3 divided by 2 is 3 halves. That's the same as 1.5. Okay, so 3 feet plus 1.5 feet equals 4.5 feet. Okay, 4.3 says Lola's hamster walked 6.5 feet and then half of that length again. Okay, so this is going to be 6.5 feet plus, we got to do 6.5 divided by 2. Okay, 6.5 divided by 2. It's going to get messy. I wrote this too high. So, no, I'm going to change this. I don't want to deal with that mess. Okay, so I know 2 goes into 6 3 times. Subtract it down real quick. And then 2 can go into 5 2 whole times. There's 1 left over. So that means it can go 2.5 times. So I'm going to skip a step here. And I know that this is going to come out to 3.25. And so 6.5 feet plus 3.25 feet equals 9.75 feet. Or 9 3/4 if you like that better. Okay. The last one says Lola's mom walked X feet. So this is when in math they say something happened X times or there's X amount. That's just a way of telling you that it's unknown, and they want you to write an expression using that variable, using the variable X, for this unknown quantity that will work no matter what the unknown quantity is. In math, we call this generalization. We want to write a general expression that works for all these same things. So Lola's mom walked X feet and then half of that length again. So it's X for the original X feet that she walked, right? And then we always wind up adding that same amount divided by 2 to the to this first part. And so I can write that as X over 2. And that's going to equal, well, let's see here. I have X plus X over 2. This is 1X. I could write this as 2 over 2x plus x over 2. Or how about this instead, 1/2 x. So all I've done here is I've taken this original x and I've written it as 1 times x, but the 1 is represented by a 2 over 2. And I only did it that way because I knew I had a 2 on the bottom of the other x. Now they're easy to combine. This is called combining like terms. You don't need to know how to do this just yet. You'll need to know how to do it pretty soon. Honestly, you could probably just leave this as your answer right here. But we're going to get fancy with it and write it as 3 over 2x. If you don't really understand how I went from here to here, I would not worry about that. That will be something that both mine and Mr. Wong's class will be studying sometime after winter break, like February or something like that. All right. So these explore questions are hard sometimes, and I did not do this in advance. So hopefully I don't mess this up. Let's see. Using the digits 0 through 9, no more than once each, fill in the boxes to create an accurate number line. How many solutions can you find? Okay, so on the top, we have a numerical number line. And then on the bottom, we have a percent number line. And we're supposed to make it so that whatever this value that we put in here, these 2 digits, will be 100% of our amount. And then we have to use the remaining digits to pick some amount that is between 0 and the full amount that we've chosen, and a percent that accurately represents that amount. And they said they wanted to be an accurate number line. And so I think that means that we're supposed to pick numbers that sort of make sense for how the number line looks. And so like this, this value here seems to be, I don't know, maybe like a third or so of the way to the full amount here. So maybe we should keep that in mind. Like if this were, I don't want to, I guess I can't really do a third, because if I put whatever value is here as a third of this, that would mean that this has to be 33.3 repeating percent. We can't have that because I'm only allowed to use 3 one time, so I can't make this 33%. So I don't know, how about 30% then instead? Okay, so this is gonna be hard. I wonder if we're allowed to put decimals. Okay, so there's one that works. It's not accurate to how the number line really looks, right? We made our whole amount 86, and then the amount on the number line 43, that's half. And so that would be 50%. And I didn't double up on any digits, right? 0, 5, 3, 4, 8, 6. So that answer works. It's not technically really very accurate, but hey, I should have done it ahead of time so I have a better answer for you. I tried to think of one real quick. If you can come up with a better one than that, that's more accurate, like your percent here is maybe something more like 25, 30, 40%, something like that. That's great, but that's the one I'm going to give you. All right.